Hi, welcome to my house. I'm recording my video from home right now. I'm going to be out for jury duty today, unfortunately, so that's why I'm not here. Um, so I've cut this back a little bit today so that we just start with kind of the basic ones. I'm going to go ahead and skip around a little bit because I think it's going to be a little bit tricky to try and do if I'm not there. So you're getting to take it a little bit easy today. So what section 5.5 is about, and this is still in the notes packet that you already have, is solving trigonometric equations. You're going to want your unit circles, which is why I'm doing the dorky little screen capture where you can see me in the bottom because I want to be able to show you what you need to do on your unit circles. So a simple example of solving a trig function would be the sine of x equals 1/2. So one possible solution would be pi sixth because here's the graph of y equals the sine of x. At pi 6, the value is 1/2, but at 5 pi 6 and 13 pi 6, and so on, because it keeps coming back up as a cycle, those are other options. Now, the way we would look at this on our unit circle is if I'm solving for where the sine of x is equal to 1/2, then I want to find my triangles that have their y value as 1/2. So you can find those on your circle, kind of follow along. And so here's what I get. And you can see that the two places throughout the circle where I get positive 1/2 for my sine, which is the y, is at pi 6 and at 5 pi 6. But remember that we can go around the circle as many times as we want. So those are not actually the only solutions to that equation. They are the only solutions from 0 to 2 pi, but if I don't restrict my domain, I can keep spinning around as many times as I want. So that's something that we're going to take into account. So if we look here, the way that we would find all possible solutions, that would mean infinitely many times around the circle, you're going to just first pick the solutions on your circle. So from 0 to 2 pi. And then what number 2 says is we're going to add any multiple of 2 pi to that solution in order to represent the infinite possibilities. So here's how we would write this. N is going to be just any integer, so that's going to represent our multiples of 2 pi. If n is 0, that means I'm just within one circle. If n is 1, that would be an additional time around the circle. If n is 2, that would be adding 4 pi, so that'd be 2 additional times around the circle, and so on. And so there's 2 possibilities, but this really represents infinitely many possibilities. Pi 6 plus any multiple of 2 pi, and 5 pi 6 plus any multiple of 2 pi, okay? So we're going to look at 3 examples today. So let's look at some examples that just involve one trig function. So to solve these, we're going to get the trig function on one side all by itself, and then we will solve for that function. Now, one thing that I want to add to this is don't forget that the period for the tangent function is only 1 pi, not 2 pi. That is important to notice when you're doing your homework tonight. It's the same process. Okay, so we are going to solve the equation 3 sine x minus 2 equals 5 sine x minus 1. And so here's Marty making an appearance. So, play down. We want to get the sine function by itself. So I'm going to start first by, this is just like solving any other equation. That sine of x is our one unit. The dog's trying to steal the blanket off the couch. That's our one unit. So this would be similar to solving the equation 3y minus 2 equals 5y minus 1. It'd be like getting the y by itself. So what I'm going to do is subtract 5 sine x from both sides. That would be like subtracting the 5y in that case. We want all the trig functions. I just always try to get them to the left-hand side because it's easier for me to process that way. So I get negative 2 sine x minus 2 equals negative 1. Now I've got all my trig functions on the left, so now I need to add 2 to both sides. That gives me negative 2 sine x equals 1. And then to isolate the sign, the last thing I need to do is divide by negative 2 on both sides. So we have sine of x equals negative 1/2. So now we have to go to our circle, and we want to find the places on the circle where the sine of x is negative 1/2. Well, that's these green triangles again, but I need to flip them over so that they're going negative this time. So these two are the ones that I'm looking at, and those values end up being 7 pi 6 and 11 pi 6. So those are the two possibilities within my first circle, 7 pi 6 and 11 pi 6. But don't forget, we want to describe every possibility, so we just add that plus 2 pi n and plus 2 pi n, and we've described every possible solution to that equation. Let's look at another one. Let's solve 5 times the sine of x is equal to 3 sine of x plus the square root of 3. Go ahead and see if you can do this one on your own and check your answer. So I'm going to start this time by subtracting 3 sine x from both sides. That's going to give me 2 sine x equals the square root of 3. Then we divide by 2, and so we get the sine of x is equal to the square root of 3 over 2. Henry, no. Oops, that's not supposed to be a negative, sorry. It's positive square root of 3 over 2. So now we're looking on here. Again, sine is the y. If it were cosine, we'd be looking at the x's. That'd be the only difference. So we want to know where the sine is equal to the square root of 3 over 2. That's going to be your tall triangles, these two. Okay, so looking at this, I'm at pi thirds and 2 pi thirds. So those are our possible solutions for x. Again, we're representing every single angle, so we have x equals pi thirds plus 2 pi n, and we have x equals 2 pi thirds plus 2 pi n. Okay, so that's what we're going to do for those. Let's look at one last example. We're actually going to skip number 3 for right now, and we'll catch up on that the next day because that one's a little bit tough to try and explain to you when I'm not there. So let's go ahead and skip ahead to number 4. The only difference here on number 4 is that they've given us a restriction on the domain. So they're telling us instead of listing all solutions, we only want solutions between 0 and 2 pi. Well, 0 to 2 pi, that's one time around the circle. So all we're trying to find is the locations on the unit circle where this is true. So where is the sine of x? Henry, where is the sine of x equal to the square root of 3 over 2? That's the same one that we just did, pi thirds and 2 pi thirds. But we're not going to do the plus 2 pi n's because that's all we've got. So x is equal to pi thirds and 2 pi thirds because we only want those values that are on the unit circle right here. Okay? I believe that's where we're going to go ahead and stop for today. And then we'll have to play a little bit of catch up, but I think it'll be easier if I'm there. So you have a My Math Lab assignment for tonight, and you can go ahead and get started on that.